using the Pythagorean identities to help solve problems. And this is going to be something that's an option for you because I'm going to show you two different ways to do it. Okay, so the first way is by using the Pythagorean identities that we just established. Okay, so if you know that you're dealing with sine, and what we can do is we can use the cosine squared theta plus sine squared theta is equal to 1. So the regular trig or the regular Pythagorean identity. Okay, and what we can do here is if we want to find the remaining trig ratios, okay, we can use this to find the other values. So if we know that the sine is 12 over 13, we can write it in this form. And so then it's just a matter of solving. So 144 over 169 is equal to cosine squared theta, and that's, or plus cosine squared theta is all equal to 1, but let's put 1 in terms of the same fraction, 169 over 169. So if we subtract this 144 over 169 from both sides, we get cosine squared theta is equal to, and when we do the math on this, we're left with 25 over 169. Extract our square root. Now, the one thing with extracting a square root is you have to keep in mind that you have to consider both the positive and negative root of that, so plus or minus. The square root of 25, which is 5, and the square root of 169, which is 13. So what we see right here is that the cosine of theta is either going to be positive 5 over 13 or negative 5 over 13. Well, the fact that it's in the first quadrant means, is our cosine positive or negative? In quadrant 1, our x's are positive, so we're going to use the positive version of that, so 5 over 13. Okay, so the way that this problem here is set up is that you can use the Pythagorean identities to find that information. Okay, now, this is because this is where it's located. This is what they're asking you to practice a little bit. But for me, again, I would prefer that you do it the most efficient way. Okay? And more than likely, the most efficient way that you can approach a problem like this is if you sketch it. So if you know you're in quadrant 1 and you sketch a right triangle that label your angle at the origin as theta. And then if you use the SOHCAHTOA relationships, you can find all of these much quicker than trying to go through this process. Because if the sine is 12 over 13, sine represents opposite over hypotenuse. And so what we can do is now use Pythagorean Theorem, find the remaining side here. So I'll call that a for right now. I have a squared plus 12 squared equals 13 squared. Now, you might recognize this is a common triple, right? 5, 12, 13. If you do, you can enter that right away. If not, you would solve through this, and you'd get the similar calculations that you used over there. A squared is equal to 25. Extract the square root. A is equal to 5. Now, again, it could be plus or minus 5. Because it's in the positive direction, it's a plus 5. And once you get this form, it's much easier to find all the remaining ones, because tangent is opposite 12 over adjacent 5. The sine we already have. And so now all we have to do is find all the reciprocals. So cosecant is the reciprocal of sine. Flip it, 13 over 12. Cotangent is the reciprocal of tan. You get 5 over 12. Secant is the reciprocal of cosine, 13 over 5. Okay, so in the same amount of time as it did to find one value here, we were able to find all the values. So I definitely would encourage you to use this form. If you use this method, what you would do next is once we had the cosine and we already have the sine, the trig identity you can use would be the tangent of theta is equal to sine over cosine. So 12 over 13 divided by 5 over 13, multiply by the reciprocal. And if you're doing that, the 13s cancel, you would get the tangent as 12 over 5. And then once you have those, you then find the reciprocals the same way that we did here. The cotangent would be the inverse, 5 over 12. Cosecant would be the inverse, 13 over 12. Secant would be the inverse here, 13 over 5. Okay, so you can do it either way. Okay? If you're doing the trig identities, you find the sine or cosine value first, and then use tangent, then find all the reciprocals.